We're going to move to southern Africa. Quite a dramatic shift from what we saw in eastern Africa with fossils eroding out of these sediments and walking around looking for them as they had recently eroded out from their long-held crypt for 2, 3, 4, 5, 6, 7 million years. And we're moving to a radically different geological setting in South Africa. Here's that map again to remind you of the sites, and the sites that we've spoken about are essentially up in either North Central or associated with the East African Rift Valley. We'll return to the Rift Valley to look at a couple of other sites a little bit later, but South Africa is really where it all began in terms of discovery. Way back in 1924, as we will learn, the first fossil, as predicted by Darwin and Huxley, was found on African soil. They pointed to Africa as the homeland for humanity because of our close similarities with the African apes, not to Asia as some other people had. But it wasn't until 1924 when an anatomist was given a fossil that he recognized immediately as what he referred to as a missing link. We don't like that term. But he recognized it as an early human ancestor and published it in 1925, and we'll talk about that in more detail. But there are a cluster of sites that we will talk about, and I'd like to name them here. Sterkfontein, big one. Swartkrans. Drumulin we won't talk about. Beautiful fossils from there, by the way. Kromdraai. And we won't talk about Makapanskat. And a recently recognized site of Malapa, but the initial discovery was made at this site known as Taung, T-A-U-N-G. As I said, it's a dramatically different geological situation. We're looking at a kind of geology which is called karst topography, which is cave topography. These are subterranean caves. You see on the left a subterranean cave, just here, where fossils are collecting. They fall through a shaft into that cave, either because they accidentally are washed in there or because they are the remains of carnivore meals, as we will see. But these were areas that were visited frequently by early human ancestors because around these openings there's usually water, there's usually vegetation that has fruits and things like that that they might have been looking for. And also you'll see that leopards played a role in this. So these living creatures, these early Australopithecus, fall into these caves and get incorporated in other sediments in the cave, which is called cave breccia. And it's a very difficult deposition to unravel sometimes. If you think about an hourglass and the sand coming through the hourglass, there's a little mound in the bottom of the hourglass, right? And sometimes the most recent grains to fall in there roll all the way down the side and are next to older deposits. So it's not always straightforward, the geology. It's not a nice stratigraphy like we had in Eastern Africa. These fossils get to be jumbled up, and that's added a great deal of challenge to trying to understand relationships between fossils, whether the fossils found cheek by jowl are actually from the same time period or from very different time periods. The other problem is that it's very difficult to come up with an age for these sites, a geological age. These are limestone caverns. These are ancient sea deposits that are being dissolved by underground water and developing this underground cavern. And then eventually water percolating down from the top causes the shaft to open, and there's an opening into the cave. So they weren't living in here. There were, of course, things like owls roosting, for example, but the hominins were certainly not living there. And then ultimately, the caves get filled in, and they're cemented by calcium carbonate, for example. So these fossils are trapped in very hard rock. It's not soft and eroding like we see in Eastern Africa. And there's a lack of volcanic sediments because it's not related to the tectonics that we saw in Eastern Africa. And so these sites have offered quite a challenge in terms of interpretation. Here's a classic example. This is actually the site of Sterkfontein, which means strong in Afrikaans. Fontein means spring or fountain, and that's its local name. This is located in the Transvaal region of South Africa, and you can see in the background, this is the winter, which means it is June and July, different from the Northern Hemisphere. And this is the African veld, the South African sort of grasslands. And you see it's very dry in the winter. And this was a very important site that was worked essentially by Robert Broom, who we'll meet shortly, and John Robinson. John Robinson is pointing to the exact spot where they discovered a beautiful cranium, which is called Mrs. Ples, and you'll understand why she's called Mrs. Ples shortly. And the techniques they use are not quite as delicate as the ones you saw us using in East Africa, where we're using little brushes or little dental picks or whatever. In this case, they were using, yes, believe it or not, dynamite. And they set dynamite charges, they drilled in, they put dynamite charges, and after the dust cleared, there was a skull in two pieces that we will see. And there is a little plaque there, but you can see the breccia that John Robinson's pointing to, the very hard brown-like breccia because it's mixed in with soil and so on. So in this video, you will be able to see the site and the exact spot where Mrs. Ples was discovered. Now, so these chunks of rock, if you pick them up, you can see fossils in them. And this was first noticed by people who were mining in the area for lime, for example, for cement manufacture. And you see just here a vise. This is a huge vise and a chunk of the breccia in there that they're breaking by pressure. And they look to see if something's important. Sometimes an important fossil gets broken, like the skull that I mentioned was broken right through here, which you will see. Now, in the field, they're collecting the material, as you can see, and screening it just here, looking to see if there are important pieces. Some places it's soft and crumbly, so they can do that. And then they're often treated in acetic acid, sort of a strong vinegar-like acid, to etch away the limestone and get closer to the fossil. And they're sorted into bins, as you see here in the work shed at Sterkfontein. And here is a short video to show you this hodgepodge of events and techniques that are going on and how they're working out these fossils from this cave breccia. So you can imagine after a blast like that, it's not particularly easy to keep track of stratigraphy. It's already jumbled up and it makes it even more difficult. Well, this is a close-up of the cave breccia. There are two little fragments of molars there, covered a little bit by the arrows, but those darker spots are enamel. And this happened when I was there many years ago, and I looked at them, and they certainly weren't from a human ancestor. These were monkey molars. And later on, they were able to take that specimen out. Now, one of the clues to environment that has been used extensively is the microfauna. Remember, we talked about microfauna. Here you see a beautiful femur. Looks like our femur, but it's only about that big. It's a little rodent femur. And you can see for scale my thumbnail right there. So these are very tiny. And you see a cranium and of a rodent of some kind just there, and one of its incisors growing out. And they have very long incisors that continue to grow throughout their lives because rodents are always gnawing. They have this peculiar thing where their teeth continue to grow because they get worn down so quickly. So what you're looking at are remains of rodents. And what that is a fossilized owl pellet. Owls go out at night with keen night vision and capture rodents and eat them. And they eat them whole. The bones don't always dissolve inside, just the meat. So in their pellets, they find the remains of the last meals. And owls sort of stayed in that region, would come back and roost in those caves and defecate. And they became incorporated into the cave breccia. And rodents tend to be very sensitive to temperature and water requirements. So it's been somewhat of a help to reconstruct what environments were like in these caves millions of years ago. And here is an example of a block of breccia that housed they were working on it when I was there, and they've cleaned away absolutely beautiful 2+ million year old teeth, as you can see. Unlike modern teeth, they don't have any cavities. They're beautifully preserved, just like the ones in East Africa. And with further work, using both mechanical means like a hammer and a chisel, or a little micro jackhammer, it's a little tool with a tip on it like this, that is called a scribe. And under a microscope, you can use that and slowly chip away the breccia to expose the original bone. And this magnificent lower jaw, or mandible here, in this picture, was what was contained in there. It's not distorted, it's beautifully preserved. It's got most of the teeth. Here you see 2 premolars and the 3 adult molars. So this was an adult Australopithecus. But it's just to give you an example of how this material is processed, and in some instances, how well it is preserved. And we'll be looking into specific sites, specific discoveries, and trying to make some sense out of those.